If you get confused, I find it easy for myself if I go like this and put the x, so wherever I see an x, then I put in the x plus h. And if it has to be squared, then you square it. If it doesn't have to be squared, you don't square it. I don't know if this one is squared. No. So just like kind of work your way that way. Don't forget, if this is more than one term, in this case I know it's not, but if it's more than one term, make sure you put parentheses and distribute the negative sign. I don't care which way you solve it, that's fine. Our goal is to eliminate the zero, the problem with the zero in the denominator, so that we can solve this. And again, this is your xy point. This is the one that you need to find the slope. Then you use the point. You can use point slope. You can use y equals mx plus b. Point slope works really nice for this because you have the point, you have the slope. All you have to do is modify your equation a little bit. You have to redo it again once you change your slope, though. Don't forget to do it again.
For the normal line, you got a slope of 1/2?
For the normal line, no, I got a slope. Nope, it should say tangent line. I think they're reversed, right?
Yeah, that's what I mean.
They're reversed. This is the normal. This is the tangent. Next guy, a little bit easier. I think, did we do this one in the example?
No.
No? Something similar maybe. So just watch when you do this guy. You're going to have to FOIL this out. This is not x squared plus h squared. This is x plus h times x plus h. This also, distribute your negative sign. I've called these all backwards, so don't ask me why. Oh no, this is, yeah, that's my normal line. That's my tangent line. All right. So use the point that we gave you. Use it for your slope. Use it for your point slope. Y equals mx plus b works the same. If you prefer that one, that's fine. Usually these are pretty easier, the ones that look nicer. Okay, this one has two x's, so don't forget when you're doing this with the x, it's got to go in here, it's got to go in here. There's where your x plus h is going. The first guy has to be squared. The second guy, you got to distribute the 2. Don't forget the plus 1. If you find at the end that something can't be reduced, it's sometimes because you forgot to plug it in this one or forgot the plus 1 after writing all that out, or forget to distribute. At this point, you should be able to eliminate anything that doesn't have an h. Otherwise, you can't factor out the h. So if something goes wrong, go back and look. It's probably this guy, or maybe you didn't distribute it. This one usually tends to be, over the years, I find that's the one that gets missing. By the time you plug in one x and you plug in the other x, you're moving on. Questions? Good? I know it's a little bit redundant, but at least it gives you a little bit more practice in this. Here's a rationalized one. And that's fine. Plug it in first. Once you plug it in, your x is your radical underneath your radical. So when you plug in x plus h, it's stuck under your radical. So rationalize the numerator. Remember, on the denominator, slide it over. This is going to cancel out nicely on top. The denominator, don't distribute it. Slide it over because your goal was to eliminate that h. And if you've already distributed it, you're going to have to factor it back out. So, and we don't care what your denominator looks like. Your goal is so that you can plug h of 0 in. That's why you went through this whole mess. So now when I plug h of 0 in, I can eliminate having a 0 down there. All this to get to a slope. And this is a good review for your rationalizing ones. said, I was kind of hoping that the limits would kind of tie a few things together. When we did the difference quotient during the year, but we never used it. And usually everything that we do, we have some kind of use for it. So this gives us a good way to use this. Your points of discontinuity, they turn into your limits, your continuous, the removable points. Asymptotes, we still do the same with the asymptotes, but we just call it your end behavior, which we did in the beginning, which way is your end behavior, going up, going down. No, you can't. You scooted away. Okay? X plus h is going in your denominator. And you're going to eliminate the h. Leave your denominator looking this bad when you finish, because now we just don't have an h to have a 0 in, and we're fine. And it doesn't matter to me which way you do this. If you do this, you can leave this one like this. You don't need the separate parentheses in there. If you do this and you find the denominator for the whole thing, just plug it in for the whole thing and do it that way. Do the top if that's what works best for you. Unfortunately, you have to do it against these factors. So you can multiply everybody by the same. I don't care if you just rationalize the top and then flip it, whichever one you're comfortable with. This is one factor, this is one factor. If you rationalize only the top, excuse me, if you find that common denominator only for the top, leave your denominator there until you flip this over. Or if you're going to rationalize the whole thing, multiply the bottom. They look a little bit messy, but they all tend to work out in the end. This was a nice one. I think we did this one, but not that point. Okay. And the last one. Again, you have two x's here. Be careful of plugging in for both x's. If you're going to notice it, as soon as you go to reduce these, that something's wrong. If you forgot something. Again, don't forget your minus 1. Oops. Don't forget to distribute this. Question? It's kind of like a little bit of work involved here. It looks worse than it is. Most of this will reduce that, and everything without the h has to be reduced, has to be eliminated. Otherwise, you can't factor out the h. So again, we're looking for what would this limit be as we approach 0. Our goal is to factor that out. Then we use your difference quotient to help you get a slope.